Alright, so next section, 10.4, trigonometric polar form of complex numbers. So first off, we have to explain what a complex plane is. So a complex plane basically looks exactly like an x and y plane, except now the x-axis is called the real axis, and the y-axis is called the imaginary axis. Okay, so the x-axis is called the real axis and the y-axis is called the imaginary axis. That is the complex plane. Now, complex numbers can be graphed. And then a little side note is the sum of two complex numbers can be represented graphically. By the vector that is the resultant of the sum of vectors. Okay, so we're going to basically be doing this right here. So the only difference is, okay, I'm going to give you like just a little example. If I said graph, right here, if we said graph 2 minus 3i, now if you remember this from when we actually did complex numbers, that's kind of where we stopped. See, now what we can do is we can actually graph this on this complex plane. So if we graph this, the real part is the 2, so we go to 2, 1, 2, and then the imaginary part is negative 3i, so I just go down 1, 2, 3, and the difference is that complex numbers are graphed as vectors and not just x and y coordinates. Okay, that's basically the whole idea of complex numbers. So, first example. Find the resultant sum of each pair of complex numbers. Express a plus bi in the rectangular form. So, basically right now what we want to do is we want to graph, we want to find the resultant sum. So all we're doing now is we are going to add these two. So it's 2 plus 3i plus negative 4 minus I. So 2 plus negative 4, which is 2 minus 4, and that becomes negative 2. And 3 plus negative 1, or 3 minus 3i minus I, which gives us positive 2i. So this right here is the resultant vector of each pair of complex numbers. Now we want to express a plus bi in the rectangular form, so what that means is we're going to graph this. Alright? We're going to graph all three of these, and you'll see why it's called the rectangular form in just a second. So we're going to graph 2 plus 3i, so 1, 2, and then up 3, 1, 2, 3. So there's that vector. And then we're going to graph negative 4 minus I. So negative 4, 1, 2, 3, 4, and then minus I is right there. And then I'm going to graph the resultant vector, which is negative 2 plus 2i. And then to graph the rectangular form, you notice that the two vectors and their resultant vector, when you combine them, they form a rectangle. Okay? So once we do this, so first off I'm gonna graph the two. So if you are just on the real axes, then you're just gonna go out to 6. So I'm gonna take this up by 2s, so this is 2, 4, 6. So there's that vector, and then this one is just on the imaginary axis, so it's just going to go down to 2. There we go. And then when you add these two, so 6 plus negative 2i, you can't combine them because they're not like terms, so this is just 6 minus 2i. So this is their sum, which is the resultant vector, and then when you graph that, it's 6 negative 2i right there. And there's my resultant vector, and you can see that it forms a perfect rectangular form. Alright, next up we have to understand the relationships among x, y, r, and theta. And you'll notice that a little bit the unit circle is going to come back into play, or at least radians a little bit is going to come back into play. So the relationship among x, y, r, and theta. To understand that, I'm first going to show you guys a little graph in the complex plane. So this is the graph of x plus yi, alright? So if I was to graph it on the real axes, let's call this guy x, and this guy is yi. So when we graph this, we end up with basically a right triangle. This is theta, this is your y, and then of course this is your radius, or your r in this case. So knowing that for every single complex number that is graphed, you end up with a vector. Let's call this OP. And you end up with these terms. You have, this is your x side of your triangle, this is your y side, and this is your radius. So what is the relationship? X equals r cosine of theta. Y equals r sine of theta. So to find y, if we have the radius and the angle, we can. Now, how do we find r? R equals, remember the magnitude formula? X squared plus y squared. And then if we needed to find theta, it's y over x. If, of course, x does not equal 0. So these all look very familiar. We literally just did them with the vector section. Alright, so the trig, or the polar form of a complex number looks like this. And the way that we get that is literally, think of it, you have x equals r cosine of theta, and you know that y equals r sine of theta. Now our complex number form looks like this. It's x plus yi, right? So if we substituted this in for x and this in for y, you end up with r cosine theta plus r sine theta I. And you notice that there is an r in common with both of these. So if you take out an r, you end up with r times cosine theta plus sine plus I sine theta. And remember, this is multiplication, so it really doesn't matter if it's here or here, but I looks better in front of numbers. So this is called the trig. This right here is called the trig form of a complex number. So this is the complex number, and this is the trig form of it. So for example, let's express 2 times cosine of 300 degrees plus I sine of 300 degrees in rectangular form. So this is the analytic solution. So the analytic solution is basically 2 times cosine of 300 is 1/2 once you put that in the calculator, plus I sine of 300 is square root of 3 over 2. Again, either you remember it from the unit circle, or you put it into your calculator. And then when you simplify that, you distribute the 2. You end up with 1 plus I and I apologize, this should have been a negative. The reason why is because this is a negative. So this is going to be negative because sine of 300 is negative square root of 3 over 2. Okay, so this becomes 1 minus I square root of 3. Okay, and you can plug that into your calculator and it does it for you. Okay, or remembering the unit circle. Alright, converting from rectangular to trig form, there are 3 steps. Step 1 is going to be sketch a graph of your x plus yi in the complex plane. Step 2, you're going to be asked to find r using, remember the equation, r equals square root of x squared plus y squared. And then step 3, you're going to find theta using tan of theta equals y over x. And then of course, don't forget to choose the quadrant from step 1 accordingly, and you'll see what I mean in just a second. Alright, so let's do this. Write each complex number in trig form. So first off, we have to start by graphing that. Okay, so let's start with the little easier one, and it's not easier or harder. Let's just do this one tomorrow. It's not easier or harder, it's just one that we can do in class. Okay, so this one right here, the only reason that this one is easier is because there are only there's one real number and one imaginary. So when we graph this, so that's step 1, let's graph this guy. So it's square root of 3, which is about 1 point something. So if this is 1, so 1 point something, let's call that square root of 3. And then negative I is right here. So that's negative 1. And so there is my my vector. So you notice that right off the bat, this is in quadrant 4. You need to remember this, that the vector is actually in quadrant 4. I should have probably made this graph a little bit bigger. And actually, you know what, I'm going to cross this out really quick. I'm going to make the graph a little bit bigger. So square root of 3, let's call it right there, and then 1, we'll call it right there, or -1. So there's our vector. And now, of course, we're going to make our little right triangle. This is going to be our y, and this is going to be our x, which is square root of 3. I don't know what my theta is, and I don't know what my r is. So step 1 is drawn. Step 2, we want to find r. X is square root of 3 squared, and y is 1 squared. So r is 3 plus 1, which is square root of 4. So I got my r, square root of 4. And then step 2, we want to find theta. Step 3. So we're going to do tan of theta is equal to y over x, which is -1 over square root of 3. And tan of -1 over square root of 3, remember you multiply by the conjugate, so you end up with negative square root of 3 over 3. And you can do the inverse of that directly in your calculator, but this is supposed to be in radian mode. And if you remember, we do know where tangent is square root of 3 over 3. So theta is equal to the inverse of square root of 3 over 3. And if you remember correctly, because this has to be, there's two places where this is in quadrant 4. So you can either say it's not 5 pi over 6, 11 pi over 6. I think I'm mistaken, but whatever, let's write that down. 11 pi over 6, because it's in quadrant 4. Okay, and now we can write down the polar form of square root of 3 minus I, which is 2 times cosine of 11 pi over 6 plus I sine of 11 pi over 6. And we are done. Alright, we'll do this one together in class tomorrow because I know I kind of rushed through this. Alright. Next up, we have to do the product theorem and the quotient theorem. And then we want to find each product in rectangular form using exact values. So, alright, I'm going to stop the video right here. We can do these last two tomorrow because they're going to take about 10 minutes. In class at least. They would have taken 5 minutes in this video, but I have to redo this video and repost it. Alright, enjoy. This is not hard as long as you follow the steps and you practice. So why don't you try to do this one on your own at home. I'll kind of give you a bit of a start. Basically, this is -2, so on the real axis it's going to -2, and I'm going to go up by 2 ticks. So this is negative 1. This is negative 2. And then this is 2 square root of 3. So it's about, I don't have my calculator on me, but about 2.6. So this is 1, 2, 3. So if square root of 3 is about 1 point something, times that by 2, so we're going to end up approximately 2 something. So right here, let's call that 2 square root of 3. That's on the imaginary plane. So negative 2, 2 square root of 3. There's my vector. And then I have my x and my y. I don't have my r, I don't have my theta. So you need to find that. Done. Enjoy.